My name is Farshad Ahmadi. I'm a PhD student at Eastern Mediterranean University. I did this work with Associate Professor Dr. Mehmet Bodur. Today we are talking about the comparison of forecasting methods of house electricity consumption for Honda, a smart home. First, I will talk briefly about the work and aim and objective of this work. I'll give you the details about the dataset preparation, and time terms that we use to forecast the different models. Our forecasting models are built from the three famous methods in this field: electricity consumption, bidirectional recorded neural network, support vector regression, and subtractive clustering. And at the section 4, we will talk about the model performance evaluation. And at the last section, I talk about the conclusion of this work. So aim of this work is to develop home energy management system by forecasting electricity consumption forecasting, which is electricity consumption forecasting enables the development of home energy management system, which resulting decrease the total energy consumption, and we can decrease the total energy consumption. Of course, in the future, we can design more sustainable houses. The electricity consumption of the building composes a major part of the city's energy consumption. Because of that, we chose the domestic section inside the city. Due to the several researches, domestic energy consumption increasing due to several factors like the population growth, like greenhouse gas emissions and globalization. So I was telling that we chose the domestic section of the house. The domestic energy consumption has been increasing due to several factors like globalization, greenhouse gas emission, and population growth. So the importance of energy efficiency and increasing energy efficiency is growing every day, and forecasting plays a key role in it. Also, energy management utilizing optimized energy forecasting of the domestic houses, that this leads us to increase the energy efficiency of the house and the utility of the renewable sources such as solar panels. It means that with the same amount of energy, we can use more energy efficiently in the renewable sources like the solar panels. To do our work, we chose Honda Smart Home US database. Honda Smart Home US dataset constructed in California, USA, around 2015 with the goal of creating a zero life carbon stack and creating a sustainable house. So we found it very ideal for our work. They started to collecting data from a house that is in California. They put sensor inside different devices and start to collecting data. So we use this data set to compare our methods, three popular method in this area: electricity consumption, ANN or artificial neural network, support vector regression, fuzzy rule-based system for regression. To get the lowest error, our error are MAE and RMSE to get the lowest error, and by building a model from each method, like we will build like 5-6 relevant methods from ANN or support vector machine. We choose the best model out of this method and we will compare them together, and we will come with a result. So our data set, Honda Smart Home project, as I told you, they constructed in 2015, and the data related to energy management, such as HVAC or heating, ventilation, and air conditioning system. And they were collecting like HEMS, or host energy management system data, and the data are recorded at every 1 minute sampling rate. The thing I have to add is they started to record the data from 2015. We didn't capture all this forecasting study is based on 6 months data that gathered by them from October 2020 to March 2021. And due to the lots of electric devices like microwave or washing machines, the dataset contains lots of zeros, so the dataset is sparse. Energy performance of the building is influenced by many factors, like the humidity, like the temperature, and variety of the electric devices. So for this study, multivariate machine learning models are actually preferred over univariate for domestic electricity consumption forecasting. And our model compared with each other in 3 time terms: medium time terms, short-term electricity load forecasting, and very short-term electricity forecasting. Medium terms electricity load forecasting is usually up to a week to a year. Short-term electricity load forecasting is usually up to an hour to a week, and very short electricity forecasting is up to minute to an hour. And there are different actually usage of them. Medium term, usually they're using for maintenance, schedule, and planning power system outage. For short term, the primary application is daily operation of electric power system. For very short term, the main usage is that they covered the main use is the real-time controlling. The very short-time electricity load forecasting, or VSTELF, of this study used 10 random sample of 70-minute data collected over a 6 months period. It means that our data is 6 months. The data is randomly selected from this, probably around 10,000 rows of data. For very short time, 70 minutes data is randomly selected for the statistical parameter for forecasting performance evaluation. And similarly for the very short time and medium time, we use again 10 pieces of 4 days and 2 months. It means that 4 days for short time, 2 days for training data, and 2 days for actually forecasting, and 2 months for the medium time, 1 month for the training data, and 1 month for the test data or forecasting data. And this data randomly again selected within this 6 months data period for comparison. And the reason we use different time terms and different and randomly selected data, that we aim to demonstrate more of the model's weaknesses and strengths by cover different modes of the power consumption and show the weaknesses and strengths better. In this table, you can see the data set that we obtained from the Honda data set. The first third, BRNN, SVR, SVC, they're showing the training. And the third one that I wrote all models, that one is the very short time test data. For the very short time, we use 70 minutes, as I told you. We use 60 of them, means because they captured every 1 minute, 60 minutes has been an hour. So we took an hour to predict in the next 10 row or next 10 minutes for this time term. As you can see, there is a very low amount of training data for the forecasting. SVR and SPC, both of them using 60 for training, but BRNN from that 60 using 30 for the training and 30 for the verification. But the test data is same, 10. For the sampling period in this time is 1. For the short time, we use 3,000 rows of data. It means that about 2 days, they're covering 2 days. Sampling rate is 1. And testing data is 3000, like 2 days as well. So we will see 2 days and we will forecast 2 days. For the medium time term, actually we chose 80,000 lines of code. That 40,000 lines of codes are for training data and 40,000 for test data. But because we reduced it to the reasonable size, we did the sampling by 10. So the data reduces to 4,000 and 4,000. Again, BRNN using 2,000 for the training and 2,000 for the verification. If you see the last column of the table, number of input attributes, we have 8 for all except the very short time. Firstly, let me tell you my outputs. My actual outputs is input variables are like lightening of kitchen, lightening of the room, washing machine, fans, AC, microwave, and we chose like 8 different input variables, and 2 of them actually they are outside factor, as they are very important for the electricity consumption of for inside the house, humidity and the temperature. So and we have just one output, that this is the sum of all of the electric devices that I mentioned. For medium time and short time, we have 8, but for the very short time, I mentioned it variable. And the reason is because the data interval is very short, just 70. It's sometimes happening that like microwave, we are just using it couple of times in the day. So it's happening that one column fully it's zeros. So when one column is fully, one column or even more than one column, like washing machine, and when one or more than one column is zeros, the model cannot scale the data to do the prediction. To solving this issue, because we don't need those zeros columns anymore, we can omit the zero columns. So our models can do the job, but we don't know like how many variables in them. To my experience, like 2, sometimes 1, sometimes 2, maximum 3 variables were omitted like this, and this will solve the problem. For choosing the models, and this is a tested number of forecasting models based on 3 mentioned methods, as I told you, ANN, SVR, and FRBS. For choosing them, we tested lots of models inside the method that I will show you the details in the following slides. But at the end, we chose bidirectional recorded neural network, or BRNN, support vector regression with ANOVA RBF kernel, or analysis of variances radial basis kernel function, and the combination of subtractive clustering SPC method and the fuzzy seaming. So our first model is bidirectional recorded neural network. So at the first, we were trying to use a basic model, like a basic feed-forward neural network. Why? Because if we can get the same result from the more basic models, that they are less computationally expensive, yes, we will choose them. So I started to test different models. I test the basic feed-forward neural network and the set of recorded neural networks, including the GRU, or gated record units neural network, and the long short-term memory. And I choose two widely used ReLU and the tangent, or a rectifier linear units activation function and hyperbolic tangent function. I tested them. At the end, the bidirectional recorded network marginally had a better result, but as you know, the deep nature of deep neural networks is like that. Every time after the forecasting, they give different results. So the average of 10 times run calculated for all of the model I mentioned above. And marginally, the bidirectional neural network was better, or BRNN was better. So we chose this model to compare it to a base model of the other methods. In here, you can see two plots. The first one is for FNNN, and the second one is for BRNN. The red line is the real value, and the blue line is the predicted value. As you can see, the y-axis is 0 to 3000. It means 2 days ahead, and the x-axis is from 0 to 1 because values are between 0 to 1 because I did normalization, min-max normalization between 0 and 1. So as you can see in this plot, the BRNN model worked much more accurate than the basic feed-forward neural network. Our second model is support vector machine by the ANOVA RBF kernel. We searched various packages and kernel functions. As you know, the various packages have different tools inside them, and kernel functions such as radial basis function, tangent hyperbolic, Bessel, Laplace, and finally the ANOVA RBF from the kernel library package provide the outstanding forecasting performance accuracy over the rest. In this method, this method, of course, supporting the regression and employ the sequential minimal optimization algorithm. And actually, I have to add, I didn't write any optimization algorithm or technique to any of the method and models that I mentioned. They are just inside the tools and inside the package because I wanted to be fair. So I didn't add any line of code as an optimization algorithm to any of them. This SMO optimization algorithm that in this packages existed reduces the execution time by breaking down the search into multiple sub-search tasks, and also the SPM saves some computational effort because managing to do the fitting processing and the modeling at the same time. Again, you can see two plots relate to SPR, one with the radial basis function, one with the ANOVA radial basis function. As you can see, the differences is huge, and RBF is a very popular actually kernel function, but as you can see, the result for this study wasn't good at all. Our third and last model is based on fuzzy rule-based system. Again, a set of fuzzy rule-based system based on space partitioning, based on neural networks, clustering, gradient descent. All of them were evaluated and determined the model with the highest performance accuracy, which was the subtracting clustering method with the fuzzy seaming technique. Again, I didn't enter them manually from the same package, and it was acceptable for this study and power consumption forecasting. If I want to tell what is subtracting clustering method doing, it considering each data point as a potential cluster center, calculates the likelihood of each data point, defining a cluster center based on its distance to all other data points. So they get the distance with all of them, and they start to build a cluster center. So this actually, the point with the highest potential, remaining points chosen as the next cluster center. This process will continue until we have obtained all of the cluster center. And at the end, fuzzy seaming algorithm is used to optimize the cluster centers. You can see the plots for here. The B is the model I just mentioned, subtractive clustering or SPC. The first one is hybrid neural fuzzy interference system using first FRBS package, all of them using, I tested all of them together. Like this one, hybrid neural fuzzy interference system was the best among even the others and you can see the difference between the subtracting method. Some of other models are used in this package. They were, we can say, accurate enough, but the execution time of them were too high that we can use them. The accuracy of all of the models measured in two metrics, mean absolute error and root mean square error, simply because these two are most common for measuring the accuracy of the electricity forecasting. And I just want to make this work more comparable to the others. And the models are comparable to each other because all of them normalized in 0, 1, mean and max normalization, and they're using the same test data. Additionally, I calculate the model execution time as well. As you can see in table 2 and table 3, the first one showing the execution time of the model, average of 10 times run and 10 random data sets. For the very short time, as you can see, these are our errors at table 2, so lower is the better. Error for the SVR, MAE and RMSE is very acceptable and actually is very good result. In the following, I'll show some plots as well, and we will discuss on those plots as well. For now, when we see the SPC and BRNN, SPC is not that good. The error is actually high, and BRNN is so high for this time term, very short time term. For short time term, again, SVR showed the best performance in here as well, but the SPC and BRNN, now they are usable. Now they are, their performance is good. They are not that bad. And for the last one, medium time, SVR again is the best one, and the SPC model showed its best performance actually in here. It showed that with the bigger data, the subtracting clustering is using better, and BRNN actually is much worse than the before. Maybe it's the effect of the sampling inside the data set. And the table 3 is showing the execution time of the models. As you can see, SVR at the very short time, all of them are around 10 seconds. At the short time, again, SVR showed the 10 seconds. BRNN is slightly increased, but SPS around 5 minutes, so like 4 minutes and 50 minutes, 50 seconds add to the execution time. And when we raise the, add to the data set in the medium time, you can see again the SPC model adding like 4 minutes more execution time to it. But SVR is the same, and BRNN very slightly increasing. So these are the plots of them, different models now. Again, the red is the real value and the blue is the predicted value. As you can see, except the SVR model, the rest SPC and BRNN, they are not suitable for the very short time forecasting. For the short time, as we can see on the plots, SVR looks a little bit better. BRNN and SPC almost showing the same results, and they are good enough if you want to use them. And again, the SVR is the best model in here. And for the medium time, as we saw in the results, BRNN is a little bit worse than SPC. And again, we can see that maybe I have made it big because in here maybe it's not that obvious, but SVR again, as the result showed, has the better results. So as a conclusion, we can say that the BRNN model worked better than the other ANN models that I tested, like GRU model or like FFNN model, because using the bidirectional layer, and this bidirectional layer processes sequence in the both direction, means that connecting the next output to the input. So, and our data is time series, so data is related to the data behind it. So this was the reason that BRNN worked better than the other models I built from the ANN method. The tangent activation function, because activating almost all input neurons to predict the output, work better than the other activation function. But both of these things I mentioned here, by using bidirectional layer and using the activation function that's activating all of the neurons, it make the model computationally more expensive. In here, because the data set wasn't that big, we couldn't see a big difference from the in the execution time. But the first time was 10 seconds, and the last one was like 50 seconds. But I think when the data set grows, this time we can see the difference more obvious. And at the end, the BRNN model is suitable for short time and medium time, but not ideal for the very short time. And the SPS model with the fuzzy seaming optimization, again, I should tell you that I didn't add any code for any optimization because I wanted to be fair. I'll perform the other tested models in that FRBS or fuzzy rule-based system package. But unfortunately, SPS is inefficient for very short time forecasting. As I showed you, this model is working with the big data set, a large data set, that makes it not suitable for very short time because it will add to the execution time and we cannot use it for very short time, but it's suitable for short time and medium time if the long execution time is not a concern for the forecast. At the end, the SVR model that constructed from the kernel library package and the tool we used that employs an SMO optimization, as I mentioned, algorithm during the modeling process. The thing I want to mention here that we saw in the short time, very short time, and medium time, all of them, the SVR was lower, had the execution time less than 10 seconds. We raised the dataset from 70 to 8,000, but it stayed at the lower than 10 seconds. The reason is this SMO optimization. I read one research that Dr. John Plate, a Microsoft scientist team member, wrote it. He mentioned that this SMO optimization work like up to actually 1,000 times faster than the other duplication techniques like chunking algorithm. As you know, chunking algorithm broken down the problems into the series of smaller problems like the SMO optimization. When actually the size of the database get big, they're doing this to help the speed of the execution time. Because of this, this Dr. John Plate in his research said that these methods with the SMO optimization algorithm working up to 1,000 times faster than the other algorithm like chunking algorithm. At the same time, the SVR, as I mentioned, handle the both fitting and the modeling process at the same time, saving computational effort. And for the more precise forecast, actually the ANOVA or analyzing and ANOVA RBF kernel is helping. As I showed you, the RBF wasn't that good in that plot, but ANOVA RBF was like a big difference because they're analyzing and comparing difference between group means or population means. In here, there are variables and their associated procedures such as variation. They're analyzing them and help the model for more precise forecast. So with these three difference of SVR model with the rest of the models, the result indicate that SVR model forecasted with the lower MAE and RMSE than the other model. SVR models showed very long execution now with any database volume. So it's very good for very short time forecasting. And at the end, implementation of SVR model was very easy. That makes it an excellent choice for the forecasting in all time terms for time series data. Thank you so much for your time and listening. If you have any question,